To determine the appropriate conductor size for a main feeder serving multiple 120/208 volt three-phase distribution panels and the sub-feeder supplying each individual panel, several factors need to be considered. Let's start with the main feeder. Based on the information provided, a minimum conductor size of 350 kc mil copper or 500 kc mil aluminum is recommended for the main feeder. This recommendation assumes standard conditions and load characteristics. Now let's consider the subfeeders. For each 150 amp panel, a minimum conductor size of 250 kc mil copper or 400 kc mil aluminum is recommended. Again, this is a starting point, and further adjustments might be necessary based on specific conditions. It's very important to remember that these are minimum sizes. The conductor size may need to be increased based on several factors. Firstly, voltage drop. Maintaining acceptable voltage drop is crucial for the proper operation of electrical equipment. Longer feeder runs will experience greater voltage drop. If the distance between the main panel and the sub-panels is significant, larger conductors may be required to compensate for voltage drop and ensure that the voltage at each panel remains within acceptable limits. Secondly, short-circuit current. The conductors must be able to withstand the maximum short-circuit current that could occur in the system. A short-circuit study should be performed to determine the available fault current at each panel. Based on this, the conductors should be sized to have an adequate short-circuit current rating. Larger conductors generally have a higher short-circuit withstand capability. Thirdly, ambient temperature. The ambient temperature in the area where the conductors are installed can affect their ampacity. If the operating environment will be hotter than normal, the conductors may need to be upsized to prevent overheating. This is because the insulation of the conductors has a temperature rating, and exceeding this rating can lead to premature failure. It is important to consult the National Electrical Code, specifically Table 310.15b16, which provides ampacity ratings for conductors based on their insulation type and temperature rating, and to apply any necessary correction factors for ambient temperature. Here are some additional considerations when selecting and installing conductors. Firstly, conductor rating. The conductor should be rated for the appropriate voltage, which in this case is 120/208 volts, and current, as determined by the load calculations. Secondly, installation method. The conductors should be installed in conduit or another approved raceway to provide physical protection and prevent damage. Thirdly, termination. The conductors should be properly terminated at each panel using appropriate connectors and lugs. Proper termination is essential for ensuring a reliable and safe electrical connection. Fourthly, overcurrent protection. The main feeder and sub-feeders should be protected by properly sized circuit breakers or fuses. These overcurrent protection devices are designed to protect the conductors from overload and short-circuit conditions. The size of the circuit breaker or fuse should be coordinated with the ampacity of the conductors to ensure adequate protection. To summarize, the minimum conductor sizes for the main feeder are 350 kc mil copper or 500 kc mil aluminum, and for each 150 amp panel, the sub-feeder size should be 250 kc mil copper or 400 kc mil aluminum. However, these sizes should be adjusted based on voltage drop, short-circuit current, and ambient temperature considerations. Always consult the National Electrical Code and other relevant standards to ensure compliance and safe installation practices. Consider a scenario where the sub-panels are located a significant distance from the main distribution panel. In this case, voltage drop becomes a critical factor. To calculate voltage drop, you would use the following formula: voltage drop equals 2 times the length of the conductor in feet times the current in amps times the impedance of the conductor per foot, divided by 1000. The impedance of the conductor can be found in the National Electrical Code. For example, if the distance is 200 feet, the current is 150 amps, and the impedance is 0.1 ohms per 1000 feet, the voltage drop would be 2 times 200 times 150 times 0.1 divided by 1000, which equals 6 volts. If the acceptable voltage drop is 3%, then the voltage at the panel should be at least 201.76 volts. If the calculated voltage drop exceeds this limit, then larger conductors would be required. Another important factor to consider is dirting. Dirting refers to reducing the ampacity of a conductor due to factors such as ambient temperature, the number of conductors in a raceway, or the presence of harmonics. For example, if there are more than 3 current-carrying conductors in a raceway, the ampacity of the conductors must be derated according to Table 310.15 Cone of the National Electrical Code. Similarly, if the ambient temperature is higher than 30 degrees Celsius, the ampacity of the conductors must be corrected according to Table 310.15b16 of the National Electrical Code. The presence of harmonics can also affect the ampacity of conductors. Harmonics are non-sinusoidal waveforms that can cause increased heating in conductors and equipment. If the system is known to have significant harmonic content, the conductor should be sized accordingly. In addition to the conductor size, it is also important to select the appropriate insulation type. The insulation type should be suitable for the operating environment and the voltage level. Common insulation types include THHN, THHW, and XHHW. THHN insulation is suitable for dry locations, while THHW insulation is suitable for wet or dry locations. XHHW insulation is suitable for wet or dry locations and has a higher temperature rating than THHN or THHW. The conductor should also be properly supported and secured. The National Electrical Code specifies the maximum spacing between conductor supports. Proper support prevents the conductors from sagging or coming into contact with other objects. The conductors should be secured to the raceway or enclosure using appropriate clamps or connectors. When terminating conductors, it is important to use the correct size and type of connector. The connectors should be listed for use with the conductor size and material. The connector should be properly tightened to ensure reliable electrical connection. The use of antioxidant compound is recommended when terminating aluminum conductors to prevent corrosion. Corrosion can increase the resistance of the connection and lead to overheating. Regular inspection and maintenance of the electrical system are essential for ensuring its continued safe and reliable operation. The conductors and connections should be inspected for signs of damage or deterioration. Loose connections should be tightened, and corroded connections should be cleaned or replaced. The overcurrent protection devices should be tested periodically to ensure that they are functioning properly. Any deficiencies should be corrected promptly. It's also important to consider future load growth when sizing conductors. If there is a possibility that the load will increase in the future, it may be prudent to upsize the conductors to accommodate the increased load. This can save time and money in the long run by avoiding the need to replace the conductors later on. When working with electrical systems, safety should always be the top priority. Only qualified personnel should perform electrical work. Always de-energize the circuit before working on it. Use appropriate personal protective equipment, such as gloves and safety glasses. Follow all applicable safety procedures and regulations. Understanding the principles of conductor sizing and installation is essential for ensuring the safe and reliable operation of electrical systems. By following the guidelines and recommendations outlined in this video, you can select and install conductors that will meet the demands of your application and provide years of trouble-free service. Always consult with a qualified electrician or electrical engineer if you have any questions or concerns. They can provide expert guidance and ensure that your electrical system is installed safely and in accordance with all applicable codes and regulations. Remember that this information is for educational purposes only and should not be considered a substitute for professional advice. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. It is important to note that the specific requirements for conductor sizing and installation can vary depending on the jurisdiction and the specific application. Always consult the local electrical code and other applicable standards to ensure compliance. Proper conductor sizing is not just about meeting the minimum requirements. It's about ensuring the long-term reliability and safety of the electrical system. Investing in the right size conductors can prevent overheating, voltage drop, and other problems that can lead to equipment failure and safety hazards. Take the time to carefully consider all the factors involved in conductor sizing, and don't hesitate to seek professional advice if needed. The cost of oversizing conductors is often minimal compared to the cost of repairing or replacing damaged equipment or, more importantly, addressing safety concerns. Consider using a conductor sizing calculator or software to assist with the calculations. These tools can help you to quickly and accurately determine the appropriate conductor size for your application. They typically take into account factors such as voltage drop, ambient temperature, and the number of conductors in a raceway. Before making any decisions about conductor sizing, it's essential to have a clear understanding of the load requirements. This includes the total current draw of all the equipment that will be connected to the circuit, as well as any future load growth that may be anticipated. Accurate load calculations are critical for ensuring that the conductors are adequately sized. It's important to remember that the ampacity of a conductor is not the only factor to consider when sizing conductors. Voltage drop, short circuit current, and ambient temperature are also important considerations that can affect the performance and safety of the electrical system. Ignoring these factors can lead to problems such as equipment malfunction, overheating, and even fire. The National Electrical Code provides detailed guidelines for conductor sizing and installation. It's important to be familiar with these guidelines and to follow them carefully when working with electrical systems. The NEC is updated regularly, so it's important to stay current with the latest edition. In addition to the NEC, there may be other applicable standards and regulations that must be followed. These may include local electrical codes, utility company requirements, and industry-specific standards. It's important to be aware of all applicable requirements and to comply with them fully. When selecting conductors, it's important to choose a reputable manufacturer and to ensure that the conductors are properly labeled and certified. This will help to ensure that the conductors meet the required performance standards and that they are safe to use. Counterfeit or substandard conductors can pose a significant safety hazard. Proper grounding is also essential for electrical safety. The grounding system provides a low impedance path for fault current to return to the source, which helps to protect people and equipment from electrical shock. The grounding conductors must be properly sized and installed in accordance with the National Electrical Code. Regular testing and maintenance of the grounding system are also important to ensure its continued effectiveness. In conclusion, proper conductor sizing is a critical aspect of electrical system design and installation. By carefully considering all the factors involved in following the applicable codes and standards, you can ensure that your electrical system is safe, reliable, and efficient. Remember that electrical work can be dangerous, and it's always best to consult with a qualified electrician or electrical engineer if you have any questions or concerns.